This time, we will look at the Ne555 timer IC, how to generate frequencies with it, and its advantages and disadvantages. This IC is an 8-pin timer IC. Starting from the top left, ground, trigger, output, reset. And from the top right, VCC, discharge, threshold, control pin. This IC allows you to select one of three modes. First, unstable mode. When power is connected, it automatically generates a continuous square wave pulse. Second, monostable mode. It is normally in a low state, and when it receives a signal, it outputs a momentary high pulse. Third, bistable mode. It works like a simple flip-flop. It is turned on by the trigger pin and turned off by the reset pin. Among the three modes, the one we will use this time is the unstable mode. The discharge, threshold, and trigger pins are mainly used to create high-frequency signals. The waveform used by the Ne555 is a square wave. The frequency value can be adjusted using the RC value set at the discharge, threshold, and trigger pins. Let's try to generate a 30 kHz frequency using this IC. We will place a 0.1 microfarad capacitor, 180 ohm resistor at R1, and a 150 ohm resistor at R2. Now, I have placed the decoupling capacitor and other components in the circuit. The calculation formulas are as follows. You can perform the same calculation if you use the LMC or ICM IC. These three components are the critical parts that determine the IC's output frequency. Next, let's look at the duty cycle. In this calculation, the duty cycle can be expressed as follows. The duty cycle is 68.7%. This means that the IC's output is high for this percentage of time and low for the remaining time. A perfect square wave, where the high and low times match, is created when the duty cycle is close to 50%. This circuit can be used to build a simple LED flasher or an SMPS. Finally, let's look at the advantages and disadvantages. First, the advantages. Simple circuit. You can create a frequency using only an inexpensive IC, 2 resistors, and 1 capacitor, and a strong IC output current. It can output up to 200 mA. Next, the disadvantages. Potential for IC heat generation. 30 kHz may be strenuous for the standard Ne555, and duty cycle is not 50%. If it's not 50%, the waveform can be asymmetrical. To solve this, you may need to recalculate the register values. In this time, we learned about the Ne555 and the process of creating a 30 kHz square wave with it. If you found the video useful, please subscribe and like the channel. Thank you for watching.